Intramolecular hydrogen bonding. Okay, when hydrogen bond occurs, when hydrogen bond occurs, when hydrogen bond when hydrogen bond occurs occurs within the same molecule, within the same molecule, within the same molecule, within the same molecule, within the same molecule. When the hydrogen bond occurs within the same molecule, it is called intramolecular hydrogen bond. Intramolecular hydrogen bond. Intramolecular hydrogen bond. As an example, salicylic acid. Salicylic acid. Salicylic acid. Oh yes. This is salicylic acid. Salicylic acid. This is salicylic acid, okay? And next is this is salicylic acid, okay? Oxygen, hydrogen, single bond, oxygen, double bond, carbon, single bond hydrogen, and single bond carbon. Okay? This is salicylic okay. Next is orthonitrophenol. Next is orthonitrophenol. Next is oxygen, hydrogen, oxygen, nitrogen, double bond O. This is orthonitrophenol. Orthofluorophenols. And next is oxygen, hydrogen bond, chlorine. This is orthofluorophenols. And next is oxygen, hydrogen bond present here, that is carbon, and that is double bond oxygen. This is salicylate ion. This is salicylate ion. solid iron. Okay. It may be noted that hydrogen bond is due to dipole attraction. Hydrogen bond is due to dipole attraction. Effects of hydrogen bond are properties of compounds. Hydrogen bond affects certain physical properties such as MP, melting point, boiling point, viscosity, solubility, and density etc. Some are given as follow. First is melting and boiling point. First is melting and boiling point. Melting and boiling point. Melting and boiling point. The compounds containing hydrogen bond have higher melting point and boiling point due to hydrogen bond associated takes place with molecules, and thus molecules exist in polymeric form as HFX, H2OI, etc. The melting point and boiling point usually depend upon molecular mass. As the molecular or polymeric, their molecular mass is larger than the individual molecules, and consequently boiling point of hydrogen chloride, water, ammonia is much higher than hydrogen chloride, hydrogen sulfide, and phosphine respectively due to hydrogen bond. Okay, water is liquid, but H2S exists as gas. No hydrogen bond in H2S. Okay, the compound containing hydrogen bond have higher melting point and boiling point due to hydrogen bond association. Hydrogen bond association due to hydrogen bond association takes place in molecules. And thus molecules exist in polymeric form, and thus molecules exist in polymeric form as HFX, H2OY, etc. Okay. First point. Water is liquid. H2O is liquid. H2O is liquid, but H2S exists as gas because no hydrogen bond in H2S. H2O is liquid, but H2S exists as gas, no hydrogen bond in H2S. Okay? Second point. Ammonia is easily liquefied than HCl. Ammonia is easily liquefied than HCl. Ammonia is easily liquefied than HCl. C point. Ammonia is easily liquefied than HCl. C point. Boiling point of ammonia. Boiling point boiling point of ammonia H2O and hydrogen fluoride HF are in the order H2O is greater than HF is greater than ammonia. Okay? D point. O nitrophenol is more volatile nitrophenol is more volatile than P-nitrophenol. Phenitrophenol E. Glycerol and glycol. Glycerol and glycol have higher boiling point than ethyl alcohol. Okay? Glycerol and glycol have higher boiling point than ethyl alcohol. Okay? The boiling point of hydrides of group 15, 16 and 17 are given. If I show also this. One minute. Ammonia association. Hydrogen boiling point. Hydrides boiling point. Hydrides boiling point. Hydrides boiling point. Hydrides boiling point. Group 15, Group 16 and Group 17. Okay, that is in Group 15. Ammonia NH3 phosphine PH3 ASS3 SPH3. Boiling point is 33, 85, 55 and 17. Group 16. Hydrides H2O, H2S, H2SE, H2T. Boiling point 100 plus 100 degrees Celsius. This is minus. Plus 100 degrees Celsius, minus 59.6 degrees Celsius, minus 42.0 degrees Celsius, minus 1.8 degrees Celsius. Okay? Group 17. Hydrogen fluoride, hydrogen bromide, and hydrogen iodide. This is plus 19.4. Boiling point of hydrogen chloride is 85.0. Boiling point of hydrogen bromide is 67.7 in negative sign, and minus 35.5 of hydrogen iodide. Second is association. Okay? Second is association. The presence of hydrogen bonding in these compounds, water, Hydrogen fluoride ammonia is indicated by higher values of melting points, boiling points, heat of vaporization than shown by corresponding normal liquids. The abnormal melting point, boiling points, and heat of vaporization of water, ammonia, and hydrogen fluoride are due to association caused by the formation of hydrogen bonds. Okay. Next is the third point: physical state. Physical state. Physical state. In normal condition, water exists as liquid, but H2O exists as gas. H2O is a liquid at room temperature because of presence of intermolecular hydrogen bond. There is no such type of hydrogen bond occurs in H2S, hence H2S is a gas at room temperature. Similarly, hydrogen fluoride is liquid, whereas hydrogen fluoride is gas. Due to presence of hydrogen bond, association takes place, due to which H2O and HF are formed. Fourth point: solubility. Fourth point: solubility. Solubility. Fourth point: solubility. Compounds containing hydrogen bond are soluble in polar solvents. Okay? Compound containing hydrogen bonds are soluble. Hydrogen bonds are soluble in polar solvent. Polar solvent. Example: C2H5OH dissolve in water. Dissolve in water due to formation of hydrogen bond. Due to formation of hydrogen bond. Okay. Some organic compounds are soluble in water. This is because these compounds form hydrogen bond with water. For example, alcohol and carboxylic acid dissolve in water due to formation of hydrogen bond, while paraffin and olefins are insoluble because they do not form hydrogen bond with water. Okay. And next is viscosity. Number 5 is viscosity. Viscosity. Compound containing hydrogen bond are more viscous. Compound containing hydrogen bond are more viscous due to hydrogen bond viscosity of H2, due to hydrogen bond viscosity of H2SO4 and glycerol CH2OH is more than water. Or alcohol. More than water or alcohol. Okay. Compounds containing hydrogen bond are more viscous. Due to hydrogen bond viscosity of H2SO4 and glycerol is more than water or alcohol. Due to presence of 3 OH group, alcohol group, each glycerol molecules form so many hydrogen bonds. Consequently, in glycerol molecules, attraction is more. That is why glycerol is more viscous than water and alcohol. 6 point. Ice has less density. Ice has less density than water. Or ice floats on water. Ice floats on water. Okay. In the crystal structure of ice, the oxygen atom is surrounded by 4 hydrogen atoms. Okay. Each oxygen atom is tetrahedrally surrounded by 4 hydrogen atoms. 2 hydrogen atoms are joined to oxygen atoms by covalent bond. The other 2 hydrogen atoms are linked to the central oxygen atoms by hydrogen bond. This arrangement forms open cage-like structure, which is shown in this figure. That is oxygen, hydrogen, that is oxygen, and hydrogen, that is hydrogen, that is oxygen. Okay. Open cage-like tetrahedral structure of ice. This open cage-like structure gives rise to a large volume for a given mass of water and account for low density of ice. Since in ice open cage-like structure is present, therefore in the large gap air is trapped, and due to which density of ice is low, hence ice floats on water. Point number 7. Density of water is maximum at 4 degrees Celsius. Density of water is maximum at 4 degrees Celsius. The melting point of ice is 0 degrees Celsius. The melting point of ice is 0 degrees Celsius. Okay. The melting point of ice is 0 degrees Celsius. Okay. The melting point of ice is 0 degrees Celsius. As water is heated from 0 degrees Celsius onwards, more and hydrogen bonds are broken, so that water molecules come closer and closer one another. Thus the volume tends to decrease and the density tends to increase. The density of water increases from 0 to 4 degrees Celsius, at which it is at maximum. It is seen that up to 4 degrees Celsius the contraction factor predominates, then the expansion effect, so that volume is decreasing whereas density is increasing. Above 4 degrees Celsius the effect of expansion predominates, and thus there is an expansion in the volume of water when it is heated at a temperature more than 4 degrees Celsius. This is why density steadily decreases with increasing temperature, hence density of water is maximum at 4 degrees Celsius. Next is evidence of the existence of hydrogen bonding. Next point, 1 minute. Evidence of the existence of hydrogen bonding. Okay. First point: the anion HF2 negative present in KHF2. F hydrogen bond hydrogen fluorine, that is anion, R fluorine hydrogen bond, hydrogen, fluorine. Okay. This anion has the strongest hydrogen bond. Due to hydrogen bond, HF2 ion is formed. Then HF is H positive ion plus F negative ion and F negative ion plus hydrogen fluoride arrow mark of F hydrogen bond hydrogen F, that is minus, or HF2 negative. It has been observed experimentally that hydrogen is midway between the two fluorine atoms. The existence of hydrogen fluoride ion is the evidence of the existence of hydrogen bonding. Chlorine and other halogens do not form such compounds due to lack of hydrogen bonding, and so compounds such as KHX2, X double bonds chlorine, bromine, iodine are not available. Second point. The evidence for the existence of hydrogen bonding is also proved with the help of IR, iodine halide spectra, electron diffraction, and X-ray analysis. Theory of hydrogen bond. Next, theories of hydrogen bond. Theories of hydrogen bond. Hydrogen bond in polar molecules.